Hello folks, let's go ahead, let me pick a color, let's go blue. Alright, so today the example is on conservation of energy. Now we talked about this in the lecture, but let's kind of quickly go over this again. So when we talk about energy, we like to lump potential and kinetic energy together into mechanical, because mechanical energy is basically anything that has to do with something that makes something move. And potential energy is one of those types of energies. Remember, potential energy is stored energy, while kinetic energy is basically energy of movement. And so whenever we're looking at these two types of energies, they're related. We add them together, and that's what we call mechanical. Then we have this mechanical energy we see here, this initial energy. That's equal to the final, so energy is conserved. It may undergo some type of transformation, but still, the amount of energy that the system has to be equal. Now, there are some problems that you're going to come up with in the examples and on your problem set that we're going to lose some energy. Some energy is gone somehow. So initial energy that we have is usually the highest. And then what we're going to have is that our final energy that we have is equal to that plus something that we lost. And now we usually add it like this. Sometimes you may see it on the other side where it's subtracted from the initial energy, but I like to do it this way. So we have these three equations. Now, let's look at an example. So, a raindrop with a mass of 0.5 grams falls to Earth from a height of 0.150 kilometers. And it reaches the Earth's surface with a speed of 6.67 meters per second. And we're looking for how much of this mechanical energy is lost because of air resistance. So we're going to assume that the free fall acceleration, the acceleration of gravity, is same throughout this 1.5 kilometers. We got some conversions to do, so we'll take a look at this. Let's go ahead and underline the data. Here's the mass. Here's one height. Here's a velocity. And let's see, I think that's it. So I'm going to go back and forth between these two slides. So mass 0.500 grams. This needs to be converted because we need it in kilograms. Distance 1.5 kilometers. We need it in meters, so that has to be converted. Velocity initial and velocity final. Initial velocity is going to be 0 meters per second. Let's go back here. The final velocity is 6.67. Decimal there. All right. Anything else? Let's take a look. Mass, velocity. So what we see, if we draw a raindrop here, here's the ground. It starts off here at 1.5 potential energy, and then with no kinetic energy, and then as we hit the ground, has zero potential energy and a whole bunch of kinetic. So this is important. So kinetic energy initial is equal to 0. Potential energy final is equal to 0. And that's going to give us something good to talk about. So let's go ahead and set this up. So our initial potential energy plus our initial kinetic energy is equal to our potential energy final plus kinetic energy final plus the change in kinetic energy that we lost because of something, or let's say mechanical energy. So we said here that our kinetic energy initial is 0 because it's not moving initially, it's just sitting up there in the atmosphere. So that's 0. Finally, the potential energy is 0 because basically it's hitting the ground. So now that means potential energy initial is equal to our final kinetic energy plus the change in mechanical energy that we're looking for. So we're looking for this. So let's go ahead and move this over. So PEI minus KEF is equal to the change in mechanical energy. Potential energy mass times gravity times height minus 0.5 m, and this is going to be velocity final, and that's going to be squared. That's equal to the change in mechanical energy. So let's look at this. We got some changes to do. Mass needs to be in kilograms. So mass is 0.500 grams. 1 gram, 1,000 grams, excuse me, is equal to 1 kilogram. So the mass is equal to 0.1235 kilograms. Distance is 1.5 kilometers. We need to convert that. So 1 kilometer is equal to 1,000 meters. So that's equal to 1,500 meters. So we did all the conversions. Velocity same. Now, coming over here, now you could either take mass away or just go ahead and calculate. So we've got 0.0005 times 9.81 times height, which is 1,500, and that's minus 0.5 times 0.0005 times velocity 6.67 squared. And I'm running out of room here. So let me go to the next slide and redo this just for you guys. So mgh minus 0.5 mv squared is equal to the change in mechanical energy. Now the mass is 0.1235 kilograms. 9.81 times 1,500. So that's the mass of potential, that's the amount of potential energy that we have. So I can't talk today. 0.5 times the mass again, so 1,235 times the velocity. Now that's 6.67. And we're going to square that. And now we have, that's equal to the change in mechanical energy. This is what we lost. So let's just focus on this. So take 0.0005 times 9.81 times 1,500. And we're going to get a number of 7.3575. We're going to carry up to 4 digits to the 4th decimal point. And we're going to do the same thing with this. So 0.5 times 0.0005 times 6.67 squared. And we're going to get an amount of 0.0111. That's equal to change in mechanical energy. So 7.3575 minus 0.111, and the change in mechanical energy is 7.3435 to the third digit, and that's equal to the change in mechanical energy. And this is how much we lost. So that's a lot of energy, potential energy is lost due to air resistance. If we didn't lose this energy, that rain would be very, very hard. And again, the unit on this is joules. If you have any questions, please see me after school or during Scott time. Thank you.